Thank you so much for your time and your support. Today I'm going to share you very important training regarding hazardous area classification. If you are doing any NEBOSH training, NEBOSH IGC or any NEBOSH training, so this is one of the very important topic. NEBOSH asks question about hazardous area. How you can classify the area and what are the hazards and what are the control measures and certain other things they ask during the NEBOSH exam. Okay, so let's start our training. Please do not forget to subscribe my channel, like my videos and share with your friends and colleagues. Please provide your support. Thank you so much. So let's start. At the beginning, let's review some basic definition. We'll start with the definitions. The first one is a hazard. Okay, so how we can know that something is a hazard or not? We can say that anything which can cause harm, that is a hazard. It could be fire, it could be gas, it could be glass, it could be anything which can cause harm, that is a hazard, danger. Second thing, the risk, the probability of that harm to occur and its consequences. So if you will say that what is a risk, so basically you can say that risk is the probability, means how likely that incident can happen. If that incident will happen, what will be the consequences? Maybe the person, he will get any cut, any bleeding, maybe fracture, maybe person hand will amputate, or maybe the person will die. What are the consequences? So you have to decide the consequences. So risk is the calculation of the probability and the consequences. Now let's talk about the fire and explosion fundamentals. What is a fire? We know that fire is a chemical reaction which is combined by the heat, oxygen and fuel. It is a chemical reaction. Explosion. Explosion is a sudden release of energy causing a pressure blast wave. Usually it is result, not the cause of a sudden release of gas under high pressure. So explosion is a sudden release of energy. So whenever any explosion will happen, what will happen? The pressure will increase. And when the pressure will increase, the blast wave will come out. So that's called explosion. Now ignition sources, open flames like matches, welding, etc. Electrical sparking, spontaneous ignition, static electricity, hot surfaces, smoking, and certain other things comes under the ignition sources. Now the types of fires, as we know that there are different types of fire, A, B, C, D, E, F. As per the types of fire, we have the types of fire extinguishers. As you know that class A fire, it is a wood, paper, fabric, plastic, any solid material that will come under A. After then B, flammable liquids that will come. After C, it is a gas. After D, it is a metal. And after then E, it is a electrical equipment. And F is a kitchen fire. Sorry. Now the stages of combustion. The stages of combustion. First of all, what will happen? Induction period. In the induction period, fire will slowly, it will start to grow. And after then, it will go to growth. The high flame will start. When it will go high, it will remain steady, same. Then it will go to the decay level. So this is the stages of combustion. Clear? Then flash point, the lowest temperature of a liquid at which sufficient vapor is given off to ignite, momentarily flash when an external source of ignition is applied. Note the difference between diesel and petrol. Okay, so the flash point, how we can know what is the flash point? The flash point is the lowest temperature of any liquid at which, if any sufficient vapor is given off to ignite, so that will start to ignition. Okay, so now let's look into some common solvents and their flash points. So we have the solvent this side and we have the flash point. in degrees Celsius. First, we have the butaneon. Its flash point is -7 degrees Celsius, and after then we have the carbon disulfide. It is -30 degrees Celsius. Auto ignition temperature is 102 degrees Celsius. After then we have the diesel oil. Then we have the flash point +40 degrees Celsius. Ethyl ethanol. Then we have the -4 degree. Then ethoxethane. Then we have the -40 degrees Celsius. Methylated spirit, we have 10 degrees Celsius. Then methyl benzene, we have 4 degrees Celsius. Petrol -40 degrees Celsius, and phenethylene, it is 32 degrees Celsius, and propane we have -17 degrees Celsius. So these are some solvents and their flash point. Now the fire point, the lowest temperature of a liquid at which sufficient vapor is given off at the surface that the application of an external ignition source will lead to continuous burning. The fire point temperature is usually just above the flash point. So some of the like solvents, they have some flash point, and after then there is a fire point. When any solvent will reach to the fire point, that will start to ignite continuously. So at the fire point, any solvent will start to burn continuously. Clear? After then we have the auto ignition temperature, the lowest temperature at which the substance will ignite without the application of an external ignition source. So whenever any solvent that will reach to the highest temperature, after that it will start to ignite automatically. That we are calling auto ignition temperature. Without any source, that will start to burn. No requirement of external ignition sources, so achieve combustion as methane gas has an auto ignition temperature of 580 degrees Celsius. So at 580 degrees Celsius, when the what you call this methane gas will reach, it will start to ignite. Then we have the limits of flammability: lower explosive limit, explosive range, upper explosive limit. Lower explosive limit, insufficient fuel for combustion to occur. Then we have the explosive range. Then the upper explosive limit, insufficient air for combustion to occur. Here we can see that lower explosive limit, 0% fuel and 100% air. For the lower explosive limit, fuel will be very less, or the fuel will be 0%, but there will be the sufficient air or oxygen in the air. And explosive range, fuel gas vapor to air ratio. Then we have the upper explosive limit. In this one, fuel will be 100%, but there will be no air or no oxygen in the air. So that is a upper explosive limit and lower explosive limit. Lower explosive limit, there will be insufficient fuel, but oxygen will be sufficient. Upper explosive limit, fuel will be sufficient, but oxygen will be inadequate. The extremes of fuel, vapor or gas to air rations between which the mixture is combustible. Example of flammable limits. Now we have the hydrogen here, physical state. These are fuel, and the physical state we can get it as a gas. Lower percentage of limit, it should be fuel lower, it should be 4%, 12%, 5%, 2.5, 2%, 3%, and 2.5%. After then we have the upper percentage of limit, means upper explosive limit, 74, 74, 15, 9.5, 8.5, 32. Okay. So these are the upper explosive limit percentage, and these are the lower explosive limit percentage. Vapor from liquid, ethanol, carbon disulfide, petrol, paraffin. So these we will get in the vapor form, and these we will get in gas form. How to prevent and mitigate explosions. Now, how we can prevent and mitigate, or we can reduce the chances of explosion. First of all, ventilation is very, very important. The area wherever you are handling any hazardous chemical, hazardous solvents, or any flammable material, the area should be ventilated. There are certain ways where you can there you can achieve the ventilation. It could be the natural ventilation, it could be the forced ventilation. So there are different types of ventilation that you can use. After then, ignition sources. You have to avoid the ignition sources. Then containment. You have to, what you can do, you can, that if there is any fire or if there is any risk, that you can contain in a certain area. After then, you can exchange, then you can separate also. So you can remember this one by VICES. Now, ventilation. Ensure that any vapors given off from a spill, leak, or release from any process will be rapidly dispersed, preventing the formation of a vapor air mixture above the lower explosive limit. So that we can achieve through the ventilation. Ignition sources. Ignition sources must be removed from storage and process areas of flammable materials. If the ignition sources are generates energy above minimum ignition energy for the flammable vapor or gas, an explosion will occur. So what we have to do, we have to remove the ignition sources completely. So first of all, we have to check what are the ignition sources, and step by step we have to control them and we have to remove them. Containment. Prevent the escape of flammable materials into the workplace, which can release vapor and generate explosive mixture. So you can contain. After then, exchange. Exchange of flammable substance for a less flammable one will reduce the risk of formation of an explosive atmosphere under normal working conditions. So you can replace the diesel with the gasoline. After then, separation of flammable substances from other processes and general storage areas by physical barriers, walls, partitions, any contributes to a safer workplaces, any drainage system controlling to the zone in flammable atmosphere may be present. Source of release, a point from which a flammable gas, vapors, or liquids may be released into atmosphere, that we are calling source of release, such as flanks, vents, instruments, connection, etc. From these things, any gas, any vapor that can release in the atmosphere. Now this is a flange. In this one, if it is leaked, if it is not tied properly, what will happen? Any material, any vapor, or any gas that can leak from here. And the second thing is here, instrument connection. So from these area, any gas and vapor that can release. Then the ignition source, electrical apparatus. If there is an electrical source there, definitely you need the electrical things to run a machine. But what we have to make sure that whatever the electrical things we are using at the plant, that should be properly controlled and proper control measure is applied on the electrical sources. Now we have now source of release and source of ignition. What is missing for a fire to occur? So now we have the source of release and source of ignition. What is the next? Aim of area classification. To avoid ignition of releases that may occur from time to time, the approach is to reduce to an acceptable level the probability of coincidence of a flammable atmosphere and an electrical or other source of ignition. So the sources of ignition should be removed or reduced. Hazardous area, a three-dimensional space in which a flammable atmosphere may be expected to be present at such frequencies as to require a special precaution for the design and construction of equipment and the control of potential ignition sources. So this is 3 dimension, and this one, what you have to do, you have to control the potential ignition sources. Where is the leak and ignition sources here? Can you identify? So these are the leak as we discussed earlier. Okay, this one also, and the ignition source is maybe this one. There is a electrical. Now subdivision of hazardous area. As per UK Act 1974, there are different hazardous area that is divided between zone 0, 1 and 2. The European classification that has these zone 0, zone 1, zone 2, and the American classification, they have the division 1 and division 2. So when you read any law regarding European standard and the American classification, they have the different division 1, division 2 for the USA, and the second one, European Union, they identify these things through zone 1, zone 0, zone 1, and zone 2. Now, what is zone 0? Zone 0 means flammable atmosphere is continuously present or present for a long periods of time. So that is the zone 0. Zone 1, flammable atmosphere is likely to occur in normal operation. It means the atmosphere is not flammable, but during the process, the flammable atmosphere is likely to occur. After that, zone 2, flammable atmosphere is unlikely to occur in normal operation, and if it occur, will exist only for short period. So zone 0 is very less risky. So maybe the flammable atmosphere is unlikely to occur. If it is likely, it will occur only for the short period of time. So in these three, the zone 0 is highly risky. So the most flammable solvents and any material that will come under zone 0. So you have to divide it, your materials, your solvents as per the zone 0, 1, and 2. And grade of release. Continuous, a release that is continuous or nearly so. Primary, a release that is likely to occur periodically or occasionally in normal operation. Through vents, sample points, etc. Through that release can happen. Then we have the secondary, a release that is unlikely to occur in normal operation and in any event will do so only frequent and it will not longer for long time. And it will remain only for short period of time, like flanges, instrument connections, etc. Zones and division. Continuous release, zone 0 and 1 and division 1. Secondary release, zone 2, division 2. So these are the European standard and these are the American one. These are the codes and standard for the zone 0, 1, and 2 IEC 6079, IEP 15, API 505, and FPA 497. These for the American standards. Hazardous location type, class 1, gases and vapors. How you can identify and how you can keep certain materials, gases, and the other materials you can put in the certain other classes. So the first class we have gases and vapors. Example, what are the gases and vapors are there? Acetylene, hydrogen, ethylene, and propane. That will come. Now the group is here NEC 500 to 503, group A, B, C, D. Then NEC 505, IIC, IIC or IB plus H2, IIB, and IIA. Class second, dust. So all the flammable dust that will come under class second, like metal dust, coal dust, and grain dust, that will come under the group E, F, and G. Then we have the class third, fiber and flying, wood, paper, and cotton processing. No subgroups. There are no subgroups for these class 3. Now the class 1, an area which flammable gases or vapors are or can be present in the air in quantities sufficient to produce explosive or ignible mixtures. Example, petroleum refineries, gasoline storage and dispensing areas, dry cleaning plants, spray finishing areas, utility gas plants. So these are the one. Now the class 2. Class 2 is an area where presence of combustible dust present of fire or explosion hazard. For example, grain elevators, flour and feed mills, use or store of magnesium or aluminum powders, producers of plastic and fireworks. That will come under class 2. So these are the one for the class 2. So the dust, flammable dust, that will come under class 2 as we know that. Then we have the class 3, an area made hazardous due to the presence of easily ignitable fibers or flames. For example, textile mills, cotton gins, cotton seed mills, plants that shape or cut wood and create sawdust and flanges. These are the ones. After then, in addition to the types of hazardous location, the kind of conditions under which these hazards are present are very important. So normal condition and abnormal conditions. Division 1 is a normal conditions and a division 2 is a abnormal conditions. Class 1, division 1, class 1, 2, 3 and division 1, 2. So we have three classes: zone 0, zone 1 and zone 2 as per European standard, and as per American standard we have the two. We have division 1 and division 2. So these are the one. So after class 1, 2 and 3, so total we have three classes: zone 0, zone 1 and zone 2, and the division 1 and 2. Class 1 and division 1, where ignitable concentration of flammable gases, vapors or liquids can exist all of the time or some of the time under normal operating conditions. So you have to remember zone 0 and zone 1, where ignitable concentration of such gases or vapors which may exist frequently because of repair or maintenance operations or because of leakage. Faulty operations or equipment or processes might release ignitable concentration of flammable gases or vapors and might cause simultaneous failure of electrical equipment in such a way as to directly cause the electrical equipment to become a source of ignition. Now, class 1 and division 2 is a location in which a volatile flammable liquids or flammable gases are handled, processed or used. So it is an area where flammable liquids, flammable gases are handled, processed or used, but in which the liquids, vapor or gases will normally be confined within closed containers or closed system from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. So let's say that we have a warehouse. In that warehouse you are storing some flammable liquids or flammable containers. So in this case, whenever that container will damage, then the leakage will happen, or you will handle the containers in such a way that the leakage will happen. So only in that condition, the class 1 and division 2 that will be applicable, because that will be for the short period of time. After then, that will remove. So as you can see here, so this is the vent. Around the vent, this is the liquid surface and storage tank, and this is the grid. This is the division 1 and division 2. So this is the division 1 and these are the division 2. Now zone 1, zone 0, zone 1 and zone 2. So through this image we will try to understand about the hazardous area classification. So this is a zone 0. So suppose that this is the fuel tank like let's say the petrol fuel tank. So inside this fuel tank, this fuel will remain continuously. Okay, so it will not be removed. So as we know that zone 0 is the area where the hazard is continuously present or the present for a long period of time. So in this one, it will be present for the long period of time, or it will continuously present. So it won't be removed from this one. So this is the zone 1. After then we have the zone 0, this one. Then we have the zone 1. So in this one, what will happen if any rupture or any leakage will happen? So this will release here in zone 1. Then it will be here for the some period of time. So it will come here, the petrol. After that, we have the zone 2. So the zone 2 is a very, very less risky. So it will normally will not happen, but if any rupture or any release will happen here in zone 1, so some of the gases or vapor will be released from here to zone 2. So it will be therefore likely it will not happen, but if even though it will happen, it will remain for only short period of time. That's all. So this is the bonding wall. If there is any release, liquid surface, this is the liquid surface. If there is any release will happen, this is the bonding wall that will bond. Okay. 3 meter horizontally from the tank and above roof. 3 meter from vent openings. So this is the vent opening that will remove the any there is any vapor or any gases will store inside this one. So that will release from here. And there is a zone 0, zone 1, zone 1 and zone 2. So zone 0. So this is the zone 0. Why? Because this liquid will remain here continuously. It won't go from here. After then we have the zone 1. Why? Because the gases and vapors will come from here and it will go to the vent. So that's why it's a zone 1. Then we have the zone 2. If any release, any leakage will happen from from the vent, then it will go to the outer area. So this is the zone 2. So this is the area where we have classified the hazardous area. You can see here, there is the green one. Then we have the red one, that is the hazardous area classification. So you have to make a map also, your location map, wherever you are keeping any hazardous material. So that should be clearly identified also. So the normal people, they can easily identify where you have the hazardous area and how you have classified those areas. And gas grouping. The gases and vapors of class 1 locations are broken into 4 groups A, B, C, and D. These materials are grouped according to the ignition temperature of the substance, its explosion pressure, and other flammable characteristics. Now, acetylene, hydrogen, ethylene, and propane. Typical gas hazards and NEC Article 500, these are the gases will come under different groups A, B, C, D. And IEC group, it is IIC, IIC, IAB, and IIA. Now, group A, an atmosphere containing acetylene, that will come under group A. Group B, atmosphere containing a flammable gas, a flammable liquid produced vapor, or a combustible liquid produced vapor mixed with air that may burn or explode, such as hydrogen, or fuel and combustible process gases containing more than 30% of hydrogen by volume. Then we have the group C. Group C, an atmosphere containing a flammable gas, a flammable liquid, produced vapor, or a combustible liquid such as carbon monoxide, either hydrogen sulfide, morphine, so ethyl, isoprene. So those things, gases of equivalent hazard, that will come under group C. Then we have the last one, we have the group D, atmosphere containing flammable gases, flammable liquid produced vapor, or combustible liquid produced vapor mixed with air that may burn or explode, such as gasoline, butane, ethanol, that will come under group D. Now the temperature class. It is important to know how hot equipment gets so that hot surfaces cannot be ignition sources. So first of all, you have to know that how your equipment, wherever you are storing your flammable material, where you are storing that flammable material, even that equipment itself can act as a source of ignition. So first of all, you have to know about the temperature about that equipment. 6 temperature classes are used, T1 to T6. The lower the number, the higher. The lower the number, the higher the maximum allowable surface temperature. Temperature classification is based on fault conditions. Temperature class must be below auto ignition temperature of the gas. Now, auto ignition temperature. As we know that whenever any solvent or any material reaches to the certain temperature, that will automatically start to burn. Temperature class is assigned to flammable material based on its auto ignition temperature. Now the temperature classes, as we know that it is 6 class are there, T1 to T6, T1, T2, T3, T4, T5 and T6. So the T1 temperature, it will be above 450 degrees Celsius. Then we have above 300 degrees Celsius. T3, 200 degrees Celsius above, and we have 135 degrees Celsius above. T4 above 100 degree, T5 above 85 degrees Celsius. So we have T6. These are the temperature class, 6 classes, and auto ignition temperature in degrees Celsius. Now the material, we have the methane, and the auto ignition temperature is 593 degrees Celsius. So it will come under T1. Then we have the different material here. Then we have the auto ignition temperature. as per these classes temperature, so that will go to the different temperature class. If it is above 400, above 450, then it will go to T1, temperature 1. If it is below that one, that will go to T2, T3. If it is below 200. So as per these things, as per the classes, temperature classes, we have to divide the material. Now the selection of electrical equipment in hazardous area. The most important thing is even the electrical equipments also which we are using in the hazardous area that can also act as a source of ignition. So we have to make sure that the electrical equipment whichever you are using in the hazardous area that are standard, properly standardized, and they are safety standard we are following for all the electrical equipment. Now, factors to be considered. First of all, zone in which the equipment will be used. Where you're going to use those equipment. Zone 0, Zone 1 or 2. Sensitivity to ignition of the material likely to be present expressed as a gas group. How sensitive is that equipment? And will it act in gas or vapors? Sensitivity of the material present to ignition by hot surfaces expressed as a temperature class. Okay. Selection according to zone classification. Equipment suitable for zone 0 can be used in zones 0, 1 or 2. Equipment suitable for zone 1 can be used in 1 or 2. You can't use in zone 0. Equipment suitable for zone 2 can be used only in zone 2. So you can't go for 0 or 1. That you have to check. Now selection according to gas groups. Grouping becomes more severe in going from IIAA to IIB and C. Group B equipment may be used in place of Group A equipment. Group C equipment can be used in place of equipment for both Group A and B. Now, selection according to temperature class T1, T3, T4, T5, 6. These are the temperature class as we know already, and these are the temperature. So, types of protection. So, these are the type of protection that we have to use for our electrical equipment. It should be European Union safety codes that should be there or other standards for the safety that you have to check. Then country region standard of marking. North America, it is UL listed. Europe, this is the one. International IEC EX. These are the standard and marking we have to use. Now flameproof enclosures that we have to use. Intrinsic safety, increased safety, powder sand filled, pressurized apparatus, oil immersion, special protection, encapsulation type of protection that we have to use. Now flameproof enclosures. That is the flameproof enclosure that you can see. Even the bulb also, light bulb also that can get hot, and even that also can act as a source of ignition. Now the type of protection for which the parts which can ignite an explosion in atmosphere are inside an enclosure which will withstand the pressure of the explosion within the enclosure. Prevent the transmission of the explosion to an explosive atmosphere surrounding the enclosure. Now, intrinsic safety. Types of protection for which the energy in the electrical circuit is held so low that spark, arcs or temperature capable of causing ignition cannot occur. Include subdivision into the categories IA, IB. IA must not produce any ignition when any combustion of two faults is present. IB must not produce any ignition in normal operation when one fault is present. So that is for the intrinsic safety. Now we have the increased safety, E, for the electrical. Type of protection for which measures are taken to prevent the possibility of non-permissible high temperatures and the formation of sparks, arcs, or inner or outer parts of electrical apparatus on which these do not occur in normal operation within increased level of safety. Now, powder sand filled. The electrical apparatus enclosures is filled with powder or sand that we can do. An arc occurring in the enclosure does not ignite an explosive atmosphere surrounding the enclosure. If you will fill up with the powder or sand, what will happen if any any ignition will happen here? It will not spread. It will limit the spark or other fire. Now, pressurized apparatus, preventing the entry of surrounding atmosphere into the enclosure by holding an ignition protection gas, air, inert gas. Air you can use, or the inert gas under the overpressure in relation to the surrounding atmosphere. So what you can do, you can fill the gas here. So if there is any air, if there is any spark or anything, it will not go out. Now, oil immersion. Electrical apparatus or parts thereof are made safe by immersion in oil such that potentially explosive atmosphere above the surface of the oil or outside the enclosure will not be ignited. That the oil can be used as well. Now, ingress protection, IP. Ingress protection rating or IP ratings refer to the level of protection offered by an electrical enclosure against solid and liquids. In an environment where dust or water could damage electronic components, a sealed enclosures is used to prevent such egress, safe house the electronics. So that can be used. Now you can see here IP, ingress protection ratings guide. This for the solids, 50 ampere, 12 ampere. Rating example IP65. So these are the one. These are the waterproof that you can use. Now how do you select electrical equipment to install in hazardous area? Now how you will check which electrical equipment that you can install in hazardous area? What you have to do? Identify the flammable materials. As I already told you that you have to identify the area first of all, which zone you're going to use it. And after then you have to identify the material, gas, vapor, dust, hydrogen, LPG, gasoline. Once you identify that one, identify source of releases, how these vapors or gases or any material that can release in the atmosphere. Identify source of release and determine grade of release, and hence zone 0, 1, 2 or division 1, 2 that can be decided. Now determine extent of hazardous area. API RP500 shows typical examples of classifications of equipment in oil and gas production facilities, including the extent of the classified areas around such equipment. So determine extent of hazardous area that you can determine. So these are the one, division 1 and division 2. This is the division 1 because this is the tank and it is inside the tank where the hazardous material will remain always. And this is the division 2. This is the division 2 where any release can happen if there is any leak or any release. Now assign gas groups and temperature class. Now the gas groups, as we know that we have the A, B, C, D or IA, IB, I or C. The temperature class we have from T1 to T6. If it is above 450 degrees Celsius, then it will go to T1. Then it will, if it is below 450 degrees Celsius, then it will go to come down till T6. Now select appropriate electrical apparatus. After then you have to select the appropriate electrical apparatus. These are the one. You have to check the standard, you have to check the safety ratings, if it is European standard, if it is American standards or certain health and safety standards that you can check. Now, these are the one standard, as I said, that you have to check: European conformity mark, notified number, body, explosion protection mark. This is the explosion protection mark that you have to check if you are using in hazardous area. Equipment group, equipment category, G for gas, D for dust. If it is G, gas and D for dust. Now explosion protection code D, A, B, C, D. No, it is there. Then it is for the gas group. Then temperature code T4. Then GB, equipment protection level. Clear? Now group quiz. The elements of fire triangle are, you have to give me the answer. What are the answer? Oxygen, wood or CO2, oxygen, fuel, CO2, oxygen, fuel, nitrogen, oxygen, fuel or heat. This answer, so that you can try. Then you have in In the event of uncontrolled fire in your vicinity, your first course of action should be to activate the alarm, ask someone else what to do, run away as quickly as possible, get a fire extinguishers. What you will do? To operate the fire extinguishers, acronym PASS is often used to help us remember to, what is that? PASS. Pull the alarm or pull the pin, aim at the base of the fire, sweep, squeeze, what you will do. So pull the pin, aim at the base of the fire, squeeze the handle and sweep at the base of the fire. It is 3. A powder extinguishers can be used on which types of fire? Where you can use Class A solid materials like wood, paper, textile, or Class B liquids like petrol, diesel, or soil, oils, Class C gases, or all of the above. The lowest temperature of a liquid which sufficient vapor is given off to ignite momentarily when an external source of ignition is applied is boiling point, auto ignition temperature, flash point, or fire point. So these are the questions that you can try to answer. Areas defined as hazardous will be documented. Documented will be available. Classification under supervision of qualified registered engineer, all of the above. 8, 9, question number 10, number 11, question number 12, 13. Thank you so much for your time and patience. I hope you like my video, and I hope the information which I shared you, it is very helpful for you. And this information you can use during your NEBOSH exam, as I said earlier, and during the interview also. And this information you can use at workplace, and there's certain other things, areas that you can use it. So thank you so much for your time and patience. Please do subscribe my channel and like my videos, and please share with your friends and colleagues. Thank you so much. See you.